Here we talk about trigonometric expressions. In the case of trigonometry, they call them identities. So what we are interested in is, again, simplifying these trigonometric expressions. Okay, so to start with, let's establish some tools. One is the Pythagorean theorem, remembering that cosine x and sine x are the x and y coordinates of a point on the unit circle. We can use the Pythagorean theorem to see that sine squared theta plus cosine squared of theta is 1. And also we can see that tangent theta is sine theta over cosine theta. Okay. Also recall these definitions of cosecant, secant, and cotangent. They're just the reciprocals of sine, cosine, and tangent respectively. I remember these by seeing that the S's and C's kind of go together and the tangent goes with the cotangent. I also remember that the cosine comes before the sine and the points on the unit circle because X comes before Y in the alphabet and C comes before S. Maybe that's helpful. Okay, if you divide by sine squared and cosine squared, you can get a couple of other identities that may be helpful. I'm going to put them in a box, even though I personally always get them again if I need them from the Pythagorean theorem. So I'm going to just do a couple of examples. They're all different, so it doesn't make sense necessarily to just do a million examples as much as it makes sense for you to try some examples. Okay, so here's some examples anyway so you can see how this works. So let's suppose the question is to show that the tangent of theta, sine theta, plus the cosine of theta equals secant of theta. What I will do here is start with the left-hand side because it is more complicated. It's easier to simplify something than to complicate it in just the right way. So I rewrite tangent as sine over cosine. So then I simplify that fraction and find a common denominator, cosine. So I multiply this numerator and denominator by cosine to get that. Then I add, since we have a common denominator, the numerators add to get that. And then I use my Pythagorean theorem, which says that the cosine squared plus sine squared is 1, so I can replace the numerator with 1 and I get this. And then I recognize that this is just secant of theta. So the reciprocal of the cosine is a secant. And then I make my conclusion that I've shown it. So I started with the left-hand side, I moved through equalities, and I arrived at the right-hand side. Okay, the next example is to show that sine x over 1 minus cosine x equals cosecant x minus cotangent x. I'm going to start with the left-hand side again because it has a fraction in it, and I'm going to try to get rid of that fraction so that I can get something like the right-hand side. The right-hand side has a fraction in it too as far as reciprocals go, so it's possible we could go that way. But I'm going to anyway start from the left-hand side. What I do is I try to pick up on a trick that we kind of had with rationalization. I'm going to multiply by something that looks like that, and the reason will be evident. So I multiply numerator and denominator. When I multiply the denominator out, the cross terms cancel, and I get this. And the numerator, I just write that, hoping for a cancellation later. So, but 1 is equal to sine squared plus cosine squared. I can subtract cosine squared from both sides. I get this equation, which means I can substitute sine squared in for the denominator. That is why I did it, because I know about this. And I know if I could just get a sine squared or a cosine squared, I might be in a position to use this fact here. And to simplify. Okay, now we get a cancellation of one of the signs. So we're just left with a sign in the denominator. And then I can distribute my division. And then recognize that the reciprocal of the sine is a cosecant. And cosine x over sine x is cotangent x. Remember, tangent x is sine x over cosine x, and cotangent x is its reciprocal. So I conclude that the left-hand side is equal to the right-hand side. So this is kind of how these problems go, more or less. There's no method. You have to try to see where you're going, see where you're starting, pick where you're starting, and see if you can meet in the middle somewhere. If it looks like it's getting worse, maybe you should stop and try again. Experience will help.